If we were to take some scenario where you have positive and negative charges and plot out the electric potential at any point around those charges, then we can form something we call equipotential lines, are just lines of equal potential. Let me show you how this works. Let's take this parallel plate where one plate is positively charged and the other plate is negatively charged. We know that if we were to put a charge here, it would have a positive charge. It would have potential energy and that potential energy would, once it starts moving, push it to the other side, to the negative plate. I should also point out here that if you have a negative charge, that it will also have potential energy, and it'll be pushed in the opposite direction of the electric field lines, going from the negative plate to the positive plate. We're just going to focus on the positive charge, but please keep that in mind that negative charges do go the other way as well. So how much potential do we have? Well, while that charge is next to that positive plate, we're going to have 20 volts. When that charge reaches the other plate, it'll have 0 volts. In this case, halfway through, you'd end up with a value of 10 volts. Now you could do that for all these points in this parallel plate path, in the parallel plates. And if you connect all the points that have 10 volts, you would get a straight line going right down the middle. All the points that have 15 volts, you'd have a straight line down the middle, but they would curve to the left on the side. And anywhere that has 5 volts, basically a mirror image on the other side. So these are lines of equal potential. Anywhere along this line, you're guaranteed to have a potential of the same value. An important point here is that electric field lines are always perpendicular to the equipotentials. And so that's an important rule for equipotentials. Now let me give you another example here before I make the final point on this slide. Let's say that you have a positive charge here. Remember that your electric field lines are going to be pointing outward. And electric fields are functions of distance, which means that further out they are a little bit weaker. So I'm going to draw out a second batch of arrows here. And further out still, weaker still. Now what would the equipotential lines look like? Well, remember that they are perpendicular, and these field lines, the electric field lines, excuse me, are really in all directions. And so the equipotential lines have to always be perpendicular to all these lines. And so in order to do that, you end up with a perfect circle. And of course, I'm not perfect, so my lines aren't perfect. But these are perfect circles. This is what equipotential lines would look like around a positive charge. So I don't know, you might have 20 volts here, 15 volts here, 10 volts, 5 volts. It would drop off at a rate of, turns out in this case, 1 over R. That's how quickly it would drop off. Now, one last thing to consider, what if you have a conductor? Well, a conductor, remember a conductor, you don't have electric fields inside of a conductor. So inside of a conductor, you have no voltage. But the surface of a conductor is an equipotential itself. So I'll just draw something here for you. Just doesn't matter what the shape is. I'm going to make it some weird looking cube type of thing. The potential on the surface of that cube is going to be the same everywhere. It's going to be the same. Whatever the value is, it's going to be the same everywhere. Why? Because all the charges will be distributed on the surface of this conductor. So you won't have any actual charges inside. All the charges will be pushed onto the surface of your conductor. Here, this is something called an electric dipole. Now, by an electric dipole, we mean that we have two charges. In this case, we have a positive charge and a negative charge. And we've already seen the electric fields between a positive and negative charge. In other words, the electric fields between this electric dipole. And those are indicated here with these red lines. This is what they would look like. Now, if we draw the equipotential lines, remember they have to be perpendicular to the lines, to the electric field lines, then your equipotential lines would look like the green lines that are drawn here in this plot.